Yeah, for my knowledge, you need a
You
bell.
pick, and then you keep going. So don't do like a 35 leg pull it. Do like
Honestly, that's just
you want to do a 5 leg pull. So
It's gonna look a little bit weird.
no, you really don't look at those. You just like
help Zay.
look at this and then just pick the
That's your
line.
lesson for today.
Oh, that's really nice.
Alright.
Oh, that's risky though. How many minutes does he get? Then I'll put the over now. Okay, that's already one. So you good at that.
If it has a red mark, if it has a red thing, it means it's risky.
No. Wemby's out.
Oh, I got him back too.
Don't think that.
I got him those.
Derek White, not this guy. Wait. No, that's Rita.
Anything's in my pocket.
Oh wait, yeah. Why is it pooping out too low?
Take this off. Take this off. Take this off.
Nah, you expect the rock. You expect the rock next.
I just said take it off. I ain't see you gotta earn that bitch. I should have told you.
No, that's too
Why you
high.
told Miles to bring his team
No,
location?
no, no.
I said, why don't you? My name is
So just go ahead and get over there and I need like.
Take the shit you do.
Oh, you might really lift this
Alrighty, good afternoon guys.
Three left.
Friday.
Or just put one more.
Yeah, so if you have notes on resistance and Ohm's laws, I'll check them now.
I got home yesterday from that award ceremony. Bless you. I was so tired. I was done.
That wasn't just me. I had to go to practice after.
Really? Oh my goodness. I was so dead.
No, I think it's
What? Oh, heck.
What do you mean? Baby just went on.
okay, then yeah, pick it.
You don't know balls. Doing no balls.
No.
I did 100 pull-ups and 100 sit-ups and 100 push-ups yesterday.
I wonder why we don't do that.
What?
That's my rice.
We more do it just because it's like
Alright,
every
check
now and then we focus on core, but we do a lot of like shoulder stuff and stuff that directly affects your shoulder.
Sounds like calisthenics.
We don't do any lifting.
Calisthenics is a lift.
Yeah.
It's the same thing.
Or did you enjoy the cadet award ceremony yesterday?
Dude, although I didn't get any of the positions I wanted, I was.
I mean, happy.
He got almost everything.
What did Elton have?
He got a lot of like personal awards, like
Notes. Alright, I've checked all notes. Did I miss anybody for notes? Going once, going
I got a
twice.
scholarship of $1,000.
So,
I saw that.
our dad joke for today is.
Everybody loves that. Elton.
I love Elton.
Yes.
If you are lying in your sleeping bag and are staring at the stars, you forgot to pack your tent.
I hate it.
I got you a water bottle back.
Bruh.
Use hers. You need this.
Alrighty guys, so let's get started. Remember, although none of you guys are seniors yet, but grad bash is today. So as soon as we're done with our lesson, or around 2:30, whichever comes first or last, or I don't know. But I'm gonna pass some of you guys off to Ms. Hines' class, and then the other half of you guys are going to Mr. Sensi's, so I can go to the auditorium to take care of the seniors as they come in. So here we go. Yes. All right. So let's get started. We are in our IB equation sheets here. We'll take a look at some new equations today, talking about resistance and Ohm's law. We will also, because as I was looking at next class has a lot of stuff in it, and this class really doesn't have a whole lot. So I'm actually going to, after I'm done with our current lesson, I'm going to do the intro of the next lesson. I've actually already adjusted the videos and stuff. However, the pods and the quiz are the same as it was before, only on the first part of our lesson, resistance and Ohm's law, not on multiple resistor circuits, which we'll talk about at the end. Okay? Cool. All right, so here we go. I'm all like hyped up and stuff. Hold on, let me get my Okie dokie. So, huh? Yeah, you juniors are going to be seniors next year. Do that. All right, so, alright guys, I really need you to stay seated and stay focused so I can get through this. Yeah. It's a bit of a stressful day. Huh? Hype for the trip. I mean, I'm always hyped for physics. But,
I'm not.
But the change is that I'm also hyped for the trip. Plus a little stress. But that just comes with the territory and being in charge of grab ash. So.
Wait, you're in charge?
Oh, no, we just go straight there. Yeah. No stopping. Alright, so let's say we have a simple circuit here. We got a battery and we've got a resistor. If you look in your IE equation sheets and look at the circuit symbols, the resistor is just a little rectangle with wires coming out of the ends here. So that's our resistor. We have our voltage from our battery, and we know that the current will flow from the positive to the negative side, from the long side to the short side of the battery. There's our current, and our Ohm's law equation controls the calculations between the voltage, resistance, and current. Easy peasy, you should have no problem with that. We should know that the resistance is really the resistance or the opposition to current, as in, if we look at our inverse proportionality here, it makes sense that the more resistance we have, the less current we have, and vice versa, okay? If we look at, God bless you, if we look at the resistance of a device, and let's keep our device simple, let's say it's a wire, okay? A wire is going to allow, because it's a conductor, it allows the easy flow of charge. We know that as we're talking about the direction of the current, we always consider conventional current, but whenever we are looking at what's actually happening, it's actually the electrons that are moving through the wire. Now, you can kind of compare it to a hose, but a hose is hollow, right? It allows the easy flow of water through the hollow part of the hose. The wire isn't hollow at all. It's solid metal, okay? Now, if you look down really, really microscopically into the atomic structure, we know that the atoms are mostly empty space, just like the solar system is, where most of the mass is concentrated at the center, aka the nucleus or the sun, if you use that model. And then the electrons are kind of like the planets, although the planets orbit in set paths, whereas the electrons do not. The typical sign for an atom is actually kind of incorrect.
Oh, cool.
Because the electrons actually don't follow set orbits. For those of you who took chemistry last year, you guys know that there's going to be like P shells and D shells and all of those different shaped probability. Basically, this is going to be the area where most likely we will find the electrons. And some of them are closer to the nucleus and other ones are further away, all that jazz. Hi, Jason. You ready? Yes. Yeah, what's up? But, so we've got this wire, although technically a wire's got like trillions of atoms, right? So even though the atoms are mostly empty space, there's a lot of them. So basically, the electrons in the wire as they go, because it's attached to the battery presents a particular voltage, it sets up an electric field, it exerts forces on the charges like we talked about last class, but it's not a straight shot. The electrons just don't zoom down the wire, they're gonna run into stuff, okay? In fact, they're gonna run into a lot of stuff. If you were to track the motion of like one charge, it's gonna kind of be like this over time.
Wow.
Where it's constantly colliding with a whole bunch of stuff inside, but eventually it kind of drifts over to where it needs to be, okay? Now, keep in mind that when you turn on the light, or when you flip the switch, the light turns on instantly, okay? So we're not assuming that the charge from one end of our power source goes all the way through the light to make it light instantly, but rather all of the charges that are free in the wire system, all of them start moving at the same time, like a giant train. So even though they're not moving that fast, we're actually drifting through, they're all drifting through at the same time. So when you flip on that light switch, the charges begin moving, albeit slowly, but through the device, and it makes the light bulb turn on, okay? There are equations for drift speed, but we're not actually responsible for those, so we're just gonna hit it conceptually. Okay, so next let's take a look at, well, the properties of the wire and how that changes its resistance, okay? So our next equation here, it starts with rho, okay? That's the Greek letter rho, it looks like a swoopy P, okay? So that stands for resistivity, that's equal to the resistance of the wire times the, what, L? A over L. But I like to use it in the resistance solved form. So solve that equation for R, and you're going to get rho times L over A. So we're talking about the properties of the wire itself that control the resistance of said wire. Let me check my email real quick here. Okay. On route and on time. Perfect.
I don't know.
Number one. Okie dokie. So let's go back to this wire here. So we've got naturally the length of the wire L, cross-sectional area A, and then the rho is going to be the resistivity. The resistivity has actually two parts, okay? One part of it is what type of metal it's made out of, okay? Because as we consider, well, there's a bunch of things that the electrons are going to collide with, it really will matter the spacings of the atoms, right? So it makes sense that the type of metal that it's made out of will have different spacings of atoms, like a copper wire versus an aluminum wire, or silver, or gold, or steel, or whatever metal it is. Based on what the atom actually is, that's going to change the spacings between those atoms as they're in the solid form, okay? So there is a, not an exhaustive list, but there is a chart on page 295 of metals with different resistivities. Silver is actually the one with the least resistivity. So the less resistivity that we have, the less resistance that we have. So silver wires will actually make great conductors, but it's expensive. Yeah, but the second best option is copper. Hey, there we go. Copper is definitely not expensive, so that's why most of our wires are made out of copper.
Doesn't copper rust?
Huh?
Doesn't copper rust?
It does, but that's why usually wires are encased in plastic. rubber or some sort of thing like that, so that they don't corrode. But
So if I were to cut the wire, would I see a eroded roof?
I mean, so it's only going to rust or oxidize if it's exposed to the air.
Oh.
So as long as it's covered in plastic, it's not going to be exposed to the air, and it'll be nice and clean once you cut it. But once you cut it and you leave it open to the air for, you know, maybe a few weeks or so, then you'll start to see the oxidation. Okay, just like, remember the Statue of Liberty is made out of copper. Okay, so originally it was like a brand new penny, but now it's green. Okay, we could clean it.
It wasn't green?
Not originally.
It wasn't always
No.
green.
Have you seen a
No.
penny? It's like
So
brown.
like steel rust color is like that dark orange, but copper rust is green, and then silver rust or oxidation is more like a black color, which is why if your parents or grandparents have actual silverware, like silver forks, knives, spoons, serving utensils, oftentimes you have to clean them, you have to polish it by removing the oxidation off of it.
Who was gonna tell me that it wasn't green?
Now gold is actually not on here, but sometimes you'll see like if you get a nice HDMI cable, okay, or a nice speaker cable, if you have a stereo that has corded speakers, okay, you may find the tips are actually coated in gold. Now gold isn't necessarily the best conductor, but gold is very non-reactive, which means that it's not going to oxidize. It's not going to get that rust or corrosion on it, which is really, really useful for connectors. So like the HDMI cable is going to connect like your Blu-ray or your DVD player to your TV, right? Okay, so the point of contact of those pieces of metal is crucial. The more corrosion there is, the weaker the signal is going to be. And the picture and sound may not be optimal, but if you have a gold-plated cord, that gold is not going to oxidize, and it's going to keep that contact nice and clean, so that you get the best signal possible.
Thanks for teaching me, man. I didn't think you learned that it wasn't green.
Dude, it is literally been
Everyone's
told you for
known.
everybody since like.
Have you not seen a picture of the Statue of Liberty when it was older? It was
Have you-
like brownish.
Have you not seen old movies?
Hey, you didn't know you.
Statue of Liberty back.
What?
They said they want the Statue of Liberty back.
Please pause. I need to call the bus driver and give them instructions on where to park.
The senior lot.
I think that's the Statue of
No,
Liberty
they're
back.
not going into
They
the
said
senior
we are no
lot.
longer.
Aaron, do you mind enough outside?
Where did you go to school?
He was in Japan.
I learned it in a lot of ways. I watched movies.
It just makes sense.
There was photos. I read a book.
I actually learned it from
We weren't in
the
America.
movie Leap. It's about ballet.
Wait, what?
Hi, good afternoon. My name is John, and I am the leader of the field trip at Paxton. So I see that you guys are en route, which is great, but I wanted to give you some information about where we want you to go. I'm assuming it has you taking Edgewood up, and then you're going to make a right on 5th or Ormond Thagard. Okay. Yeah. No, so as you approach the school's going to be on your left-hand side. And so you're gonna pass a parking lot on your left. There's going to be an entrance. That road leads down to like the baseball fields. I want you to take a left right there. There's going to be a loop as you pass, and there will be a gate that will have open, and you'll go down by the baseball fields, and there's a loop that you guys can go around and park. All 4 buses have enough room to park there, that's where we're going to load. All right. Okay, great. And can I get your ETA, just so that if you get here before I'm expecting, then we have a person out there.
Come back here. We'll go to America. Sauce.
Okay. Okay. All right, that's perfect. All right, thank you much.
Why didn't you go to Germany?
Right.
Because my mom was tired of moving.
Awesome.
It's B5.2.
All right, good to go.
That's fine.
All right. So let's get back to our wire here. So the type of metal. Okay. So the metal type is definitely going to play a part in here. Also, the temperature is kind of inside the resistivity. Okay. And you guys know what happens to your phone if you leave it in your hot car.
It burns up.
It don't work, right? Yeah. In fact, it yells at you. It says, "I am too hot. I'm not going to work until you cool me down." Blah blah blah. Okay. So because as the temperature increases, the resistivity increases, and therefore the resistance of the wire increases. Your phone is basically a little computer that fits inside your pocket, which is amazing, by the way.
I know, right?
When I was your age, like, our cell phones were not smartphones. They could only, like, call people and, like, play one game. That's it.
That's disgusting.
Yeah, flip phones.
Flip phones. Yeah. Yeah. Well, so we could also text people, but texting was difficult, especially before the slide phones that had the keyboard. If you just had the 1 through 0, you had to press like 1 twice to get an A, or 1 3 times to get a B. It was annoying. I didn't text until they came out with the keyboard stuff. Yeah, because it was just ridiculous. But the idea here, though, is the warmer the wire is, the greater its resistance. If we think about it macroscopically, temperature is a direct result of the motion of the particles inside, right? So imagine these atoms, and although it's solid, these atoms in place are vibrating. The hotter it is, the more they are vibrating. So it's kind of like as you're walking through the halls, and this is kind of a good picture of what current is, okay? The more people are in the halls, the slower everybody goes through it, right? Okay, especially for those jokers who just stand around talking, taking up space. You're like, move! And they're like, what else, yo? Okay.
Or the people that walk in the whole hallway.
Yeah. So,
I think we should.
but if there are people that are moving faster side to side, kind of like to block you, it slows it down. Okay? So that's what happens with the wire. Temperature goes up, the resistance increases because the chargers have a harder time trying to get through. Okay? All right, next up, this is one is easy. The longer our wire, the greater our resistance, okay? Simple, but then the cross-sectional area here is inversely related. So the fatter the wire is, the thicker it is, the less resistance we have, okay? So that's kind of like, well, let's say if we expand the width of the hallway. That means that there's more room to go through and people go faster. Just like on a road, a 6-lane highway is going to have more room to maneuver and traffic is going to flow better than a 2 or 3-lane highway. Okay? Because there's more room to maneuver. So the metal type matters. As temperature increases, so does the resistance. The longer our wire, the greater the resistance, and the fatter the wire, the smaller the resistance. Like whenever you have to go, like when you get a car, or if you get a car, it's important to have jumper cables, right? Because you never know when your battery's going to die and all of that jazz. So, but the jumper cables, those wires, come in different gauges or sizes. And the gauge numbers, if you go to the store and you look at them, the gauge number is opposite of what we think it is. The smaller the gauge number, the fatter the wire. So a gauge 8 is bigger than a gauge 16. Okay, and I think it's definitely worth the extra few dollars to spring for the fatter wires, because, you know, especially, well, we want to get your car jumped as quickly as possible, so the fatter your wires, the less the resistance, the more the current, and the quicker those charges go from the good car to the bad one to make it start. Okay, so that's about it for the planned lesson. All right. So,
Sounds accurate.
let's get yes. Question? Yeah.
What is the thing, the red?
What is the what?
The red.
The red? The type of metal and the temperature are both involved in the resistivity.
You know, I need glasses.
Yeah, you got it for a week.
Yeah. This is actually my wife just got me this yesterday for Gabash. But there is an error on the shirt. Can you identify the error?
No, it's not this. I don't know.
What's up? That's not really it. Because the R is part of its name. So.
Oh, no. Is it the actual T-Rex itself?
No. By the way, that's a Velociraptor.
Oh, I need glasses, please.
So, so how do we find velocity?
Don't ask me.
Acceleration.
Distance over time.
No.
Position over time. Sorry.
Oh, this is
No.
Change of position.
Displacement over time. Remember, distance over time gives you
Displacement is
speed,
speed and
which
distance, right?
tells you how fast, but it doesn't have a direction,
Isn't
so
that
it's
a
not a
vector?
vector. Velocity is a vector,
Which means you need.
so that should be displacement
I'm so
vector
smart.
over time vector. But that's okay. I'll still wear it because my wife gave it.
Is there like a nerd website for that? I'm only asking.
I'm not sure where she got it from. Most likely, she got it off of Amazon.
You need to tell her to go correct them.
shirts like that.
Huh?
You need to tell her to go correct them so you can do it the right way.
Well, see, just like the may the mass times acceleration be with you, technically that's not actually right.
Oh, I should go.
My dad.
Because
pictures like
mass
that.
times acceleration actually equals net force, not just force. I mean, it does if there's only one force, but as we talked about, there's usually more than one force acting on an object.
Mr. Vader,
You know,
Yep.
Jordan, he had an idea. He said, what if we wear like a reference sheet as a shirt for the AP exam?
Who's gonna tell me to take off my shirt?
But
Then it gets to
you
then it comes
the
to an
reference sheet.
uncomfortable conversation.
Yeah, they do give you
Like, I'm gonna put the stuff there that nobody knows
Yeah.
that's not on the reference sheet.
you know what?
So who gonna tell me to take off my shirt? Cause then it's just an uncomfortable conversation. Then it's just weird. Then I'm gonna just call
If you
weird.
show up with a shirt with equations on it, they will turn you away.
What if I make it into a joke? Be like,
What?
3.14.
You're gonna need a lot of jokes.
It is not like
Yeah,
you
make
take
it tattoo.
this.
They can't
Oh
take
my,
off
you're
my
gonna
shirt.
get a tattoo dedicated to the AP physics exam.
It's okay.
As far as you can think
I'm gonna die during
You guys. All right.
was thinking
So now we're gonna
Force
switch gears.
equals mass times acceleration.
All right. So that was that lesson. So the pods and the quiz for today are only on that stuff. Okay. The things that I'm going to talk about now is an intro to next class. Okay.
Would you
So-
get a physics test?